I would like to welcome you to the last session of the European Open and Digital Net Learning Week. This session is about design thinking and emerging technologies at school across Europe. It's actually reflecting on the first year of implementing the project Extending Design Thinking with Emerging Digital Technologies. We have organized for you 5 presentations and also some time for questions and discussion. The first presentation is about design thinking and constructionist technologies, and is by Chronis Kynigos. He will have time to introduce himself in the session that is coming. The second one is about school implementation, and is from Sofia Papavlasopoulou, Marianthi Griziotzi, and myself. The third one is about the evaluation methods we used and the pilot results we got from the first year of implementation, and is by Carina Girvan. The fourth one is about how we are planning of extending our technologies to better meet the needs of design thinking, and is by Marcelo Milrad and Marianthi Griziotzi. And the last one is about opportunities and challenges of artificial intelligence, and is by Manolis Mavrikis. I will stop sharing my screen and ask Chronis to share his and start the first presentation. Thank you for joining us.
Hello, everyone. I hasten to put up my slide, share it, and hope everyone can see. I'm just going to give an introduction to our Extended Square project. The title of my talk is not the title of the project. It's rather the title describing the rationale or the thread through which, on reflection, we feel that it was reviewed favorably. And it's, as you see, it's about design thinking with constructionist technologies. This project was proposed in a call that asked for the use of emerging technologies for transformative education. I'll just tell you a couple of things about the rationale and about the technologies we're using. First of all, it's a multi-organizational project. In Europe, we have funding of wider research issues that are dealt with organizations that have complementary expertise and work together towards a joint end. Our coordinator is Linnaeus University from Sweden, and we have a Norwegian University of Science and Technology. From Norway, we have the National and Capodistrian University of Athens, the Institute of Education at UCL. We have our SME Simple. We have Trinity College from Dublin and the OU from the UK. And all of these groups have got together for a year, and we're jointly working to do the kind of things that I will describe now. The main idea of the project is that we did not want to adopt a techno-deterministic approach to emerging technologies, which means how we use the technologies to resolve a problem in education, but rather perceive of these technologies, of emerging technologies, as affordances and tools that can be integrated into initiatives and innovations that are already promising from a pedagogical point of view. And the technologies that we wanted to integrate them into are successful media with which students express, explore, create, construct, tinker with, and discuss about doing such things. These are tools that have embedded concepts from the STEM sciences and from the arts, and they have been used for quite a while for a transformative educational practice. So we wanted to consider the use of this digital media and the emerging technologies to help and to enhance and to give a push to an innovation which is already in place in schooling, which we call design thinking, which is called design thinking, and which has been proved so far to be promising, but fallen short of the initial promises for wide-scale use. This is an innovation coming from industrial design. It's about getting kids to work in projects in small groups for them to design solutions or to design artifacts or services or problems or for the use of somebody else. They are meant, design thinking projects are meant to enhance entrepreneurship, to enhance creativity, the idea of constructing things together, the idea of design, of connecting with real world problems, of collaborating with others, of empathy, and of designing for somebody else's benefit. The rationale of the project was to pick on some emerging technologies that are promising and to join them up with our constructionist media in order to provide solutions for the problems that have arisen in the design thinking projects and their use in education so far. So we're using emerging technologies in the service of a promising pedagogical innovation and not just as an end in itself. We're integrating the technologies with successful technologies that are already in place for transformative education. And we're employing the use of this media and their extended version in the service of enhancing design thinking. Our technologies, our constructionist technologies are several. Three of them that are key to the kind of stuff we're doing are three tools with which people develop models and tinker with these models. MALT2, they develop models through programming. These are figural mathematical models, animated models, and you can see things that you sometimes have difficulty in imagining because of the digital medium. Choiko is a game designer. Students can design games based on the idea of choices with consequences and around socio-scientific games. And Sorbe stands for sorting based on educational technology. It's a Tetris-like game, only the things that are falling off the sky are objects. You have categories in buckets at the bottom of the screen, and the idea is to push the objects in the right category, and thus to think about classification issues and to design such games, which means to think about what is classifiable. The emerging technologies that we're using are augmented reality, 3D printing, analytics, and artificial intelligence and feedback. This is the way that we have been emerging them in the media, and we already have extended versions of this media where they are already in place, and we're testing them out. In our programmable modeler, we have connected it to 3D printing, and we have printouts of things that you wouldn't think, and forms that you wouldn't readily think to have objects in those forms. So that's quite interesting. We have an extension of our Choiko game where we have live geocoded maps, Google Maps behind the game, so students can create places on which they make their choices that have live data, and they can also add data according to the position that they are in real space. And with the extended game, the Tetris-like game Sorbe, we have those things falling off the sky, but we have a language to program the difficulty of the game and the density of the things falling, the speed, etc. And we have embodied interaction. Students can put a hand in front of the laptop or the screen and move the bodies with their hand, which means we can have two people, each with one hand, playing the game and trying to talk and develop a language to communicate and coordinate how they will become better at getting these objects falling in the right place. These are examples of three technologies, three such constructionist media, but we are developing more things. We are developing a special module in the Enquire platform, which is a tool to create surveys and collect data. This is the platform on which artifacts from the constructionist media will be uploaded, discussed, talked about, etc. We have technologies that allow teachers to make decisions on what kind of data they want captured and visualized while some activities going on with this kind of media. And we have a platform that arranges and administers all of these things, through which we can use the media and make decisions on who's using it, and think analytically about the data that's coming. In the project, we are not only developing all these wonderful things, but at the same time, we're gathering empirical evidence from real school settings in 6 countries. We have 3 cycles of implementation. In the first cycle, we're testing out the use of design thinking and the use of the digital media we already had in a pilot context. In the second cycle, which is to come, we will have this technology with the emerging technologies already implemented, and we will enlarge in scale. We have differences, and we're collecting diverse data from different educational paradigms, different settings, and places where there's difference in the understanding of design thinking and the experience with design thinking. And we are progressively including in our media these emerging technologies. Just to conclude, we perceive of constructionism, computational thinking, coding, as something which is evolving with a pedagogical innovation, and is not an object in itself, adjunct to any other curriculum. The idea of rapid prototyping is very important, and it's something that we all do, the researchers, the developers, the teachers, and the students themselves when they engage in the projects. Design digital media, we perceive it, as you see, as a means to co-create digital artifacts in the design thinking project. So the end result of a design thinking project is a digital artifact for somebody else to enjoy or to use. There is in our media, there's inherent programming, which we see as part of computational thinking. So that's the main thing in a gist. I hope I'm within the 10 minutes.
Thank you so much, Chronis. So yes, if you have any questions, please use the chat or the question and answer area in Zoom. And we move on to our next presentation. Thank you, Chronis, which is about the school implementations. And I think, Sofia, you should go first as soon as this becomes screen. Yeah, great.
Thank you, Thea. Yes, so I am Sofia Papavlasopoulou from the Norwegian University of Science and Technology. So I'm going to talk about the school implementations in Norway, and then Marianthi and Thea will also talk about their countries. So here we see an overview of the design thinking activities the first year of the project, Greece, Norway, UK, and Belgium. Here you can see the titles, the domains, and the technology used. And moving on to Norway, the first intervention, it was about cybersecurity, and we asked the students who participated to become cybersecurity masters. So we had 60 students. The age was 11 to 14 years old, and they were all from an international private school in Norway. The technology used was the Enquire platform and the Choico game that Chronis presented earlier. The total duration was 6 hours. We did 3 days in one day, and 3 hours in the first day, and other 3 hours in the second day. What the students were doing is that we followed the design thinking stages. First, they discovered. So what happened is that we showed some educational videos about the topic, and in our case was cybersecurity. In that way, they got engaged and they had the opportunity to learn about this aspect. Then they defined. So they used the Enquire platform or any other platform that they were more familiar with for some of the students. And they created a survey to gain insights about the topic that they have decided to work on from their classmates. Then they moved to the developed and delivered phase. So the outcome was a Choico game with a scenario that they have chosen. And that was based on a cybersecurity theme that they were more interested, like spam emails with password or anything else that they have chosen. Their reflections and some feedback that we got from this intervention was that we should give a little bit more time for the students to engage in this. And maybe it's some feedback for us that we deliver these topics, that we should have a little bit better management, because not all of them are at the same level of knowledge on the specific topic, or they need more time for this. The second that we already work on is to give the previous slide here. Yes, thank you. I was talking about the second reflection, that it was to add more functionalities on Choico that we already do, and we will use for the second year intervention in the project. And the last one was to provide more tutorials and instructions, because we observed that some of the students needed some more help to develop their ideas. Next slide. So the second intervention was in a public school in Norway, 15 students, a little bit older, 15 to 16 years old. And in that time, they engaged with a virtual robotics tool. The name of this is Gearspot. It lasted for 2 hours, 1 hour each day. And in the first phase of design thinking, they had to explore the virtual robotics environment, and that time the topic was fire rescue. So they had to see 8 objects placed in a burning building, and then they had to define a solution on how they can improve the game, which had as a goal to save these objects. Then they had to explore the block-based programming and the Python for some of the students that were more advanced and they wanted to use the Python language, and create a nice scenario, which was their own solution to this fire rescue topic that we gave them. Some reflections on this is that it was for us one-time thing about using virtual robotics, and it appeared to be a really engaging project. So this gave us the opportunity to create more design thinking activities, and again pilot them, and continue with more interventions during the second year. And of course, we had limited time, so 2 hours was not enough, and we planned for longer sessions in the future. Thank you, and then Marianthi will talk about Greece.
Hello. So in Greece, we organized 3 interventions last year. The first was with the technology MALT2, the 3D modeler, in which students had to design in this modeler a 3D vertical garden watering system. This is the intervention I will elaborate in a bit. So in this intervention, we had 30 students, 14 to 50 years old, and they were the school was a public secondary high school. The second intervention was called the topic of the project was playing with environmental issues. And in this intervention, students used the Choico game designer to create a simulation game about environmental issues. The participants were 68 students, 12 to 13 years old. And the third intervention was also with the Choico technology, and students had to design and develop a simulation game about sustainable shopping and balanced choices that we make when we shop in the supermarket. So you can see that all intervention had topics that were both scientific and societal ones. So all the 3 topics are multidisciplinary topics. So to the next slide, I will talk about the first intervention. In this one, the students had to use the MAL2 3D modeler to create a watering system for a vertical garden. The idea came to the teacher because the vertical garden is something very new, very innovative, that is used in high buildings instead of having plastic pots in the balcony. The intervention took 8 hours and followed the 4 design thinking stages. In the first stage, students had to answer a questionnaire in the Enquire platform that was designed by the teacher in order to empathize with the problem, to think what a watering system may need for a vertical garden. And then each group created their own questionnaire in Enquire to ask other people for ideas and opinions for the construction of their vertical garden. This questionnaire was distributed to other students and parents of the school, and they collected information for their project. Then in the define phase, the teacher gave to the students the code that created some basic 3D shapes in MAL2 environment, like a cube or a pyramid, and the groups had to choose which shape, 3D shape they will need and they will extend based on the results of the questionnaire that they had distributed in the first phase. So they analyzed the results they collected and they decided on a shape to use on their vertical garden. In the next stage, the develop stage, all groups created rapid prototypes of their 3D gardens in MAL2 environment, and they test these prototypes with their peers and got feedback and redesigned them. Also, they shared their models online, asking for their teachers' feedback and other students' feedback as well. In the final phase, the deliver phase, each group created a presentation of the model, the 3D model they had created, and they presented their model and the presentation in the classroom, and all students voted which of these models will be physically constructed as a maquette of the watering system. In the next slide, here you can see some of the student constructions in the MAL2 environment. These are from 2 different tools of how they solved the problem and how they thought of designing this vertical garden. And some reflections were that we got from the teacher and from the researchers was that according to the teacher, the technologies, both the MAL2 and the Enquire, where students created the questionnaire, helped them to develop some problem solving and problem posing skills, some new mathematical and programming knowledge, and also empathy about the issue, the creation of the design of the vertical garden through the questionnaires. Also, the design thinking approach enhanced collaboration and communication inside the groups, and according to the teacher, it played a vital role for their learning. However, as also Sofia mentioned, the time was insufficient for implementing all the design thinking stages in the way that the teacher initially had planned. And according to the teacher, they needed extra time for introducing the MAL2 technology and the Enquire technology to students that should had been done outside the flow of the design thinking activities. Finally, the teacher mentioned that they had difficulties in evaluating how students developed new skills or knowledge through such open-ended activities. So these are some reflections. Thank you. And next is Thea.
Thank you so much, Marianthi. So the last example we're going to talk about comes from the UK and specifically a school in Wales. The topic they selected to examine was about how to save electricity around the school. And we had 23 secondary students taking part in the study. We use Enquire as a means of collecting data about students' creations and also the Choigo game. It took 5 hours to implement the lesson. And a brief overview of what students did was that the teacher first asked them to discuss the problem under examination in order to get a better understanding of it. Then the students were engaged in brainstorming different criteria in order to create a prototype using Choiko, the parameters and how to design a game in Choiko. Then the students start designing a prototype of the game and iterating and improving it. And then in the end, they designed a study using Enquire in which they ask other students to collect feedback about their game. So they seek peer review in a way in order to improve their creations, the game they created using Choiko. What I want to emphasize here are two elements that are unique to using design thinking in teaching. And this is prototyping and revising, and also the idea of collecting feedback from others, reflecting on what you have and improving what you created. So these are two unique features or skills that students can develop when design thinking is used in the classroom. And my last slide is some reflections from the implementation. It's important to have technologies that students can easily interact with. And also in our case, because we have different tools, and also Enquire, which is about collecting feedback, and also we are thinking of this platform that may collect learning analytics. It's important to identify the best way possible to integrate different tools so it's easy for students to navigate through and engage with everyone. Also, it's important to have manuals that are easy to read and engage with. Regarding teachers and their training, we identified that more in-depth training is needed, especially for teachers to understand the connections between design thinking and technologies, because in the case of England, we had teachers that focused more on using technologies with students and creating a game, and not so much technology in design thinking, because what we've seen up to now is that design thinking has been used in schools, in some schools, not widely, but technologies are not there. And we believe that with these projects, technologies can actually improve how we apply design thinking in teaching. Also, one idea that came up from one of our teachers was to allow students to play with technologies before they start teaching them design thinking. So in a way, they familiarize with technologies, and when they are asked to do something specific with them, they are ready to start using them. Well, we'd like to thank you so much for attending this session. Our details is here if you want to reach to us. And I think we should move now to the third presentation, which I think is Carina's turn to talk about the evaluation.
Thank you very much. I'm just going to share my screen there with everyone. Thank you very much, Thea. I'm Carina Girvan from Trinity College Dublin in Ireland, and I'm going to be talking about the Year 1 evaluation methods and results. So the Exten DT² project uses a design-based research approach, which from the start integrates theory and requirements, informs the design of the interventions you've just been hearing about, which are then implemented and analyzed. An evaluation is part of this whole process. It's developed in the design phase, in the implementation phase, that's where we collect the data, and then the data is analyzed and should inform then the redesign for the subsequent cycles. In the project, we go through 3 cycles aligned to each of the years of the project. And in terms of the evaluation of the interventions in schools, in cycle 1, we're using exploratory case studies, 1 or 2 cases per country, as you've been hearing. In
Carina,
cycle 2,
would you like me to share the screen, or do you think you're sharing the screen?
oh, is it not sharing?
No.
Apologies.
No, it's not sharing.
Let's try that again. Is it sharing now?
Yes, thank you.
Yes, okay, apologies, everyone. So this is the design-based research cycle, which hopefully you're all familiar with. So let me pick up on this slide. As I said, there are 3 cycles in this project. And in terms of the evaluation in the interventions in schools, in cycle 1, we're doing exploratory case studies, which focus on 1 or 2 cases per country. In cycle 2, we're using instrumental case studies, and the advantage of instrumental case studies is that it will allow us to focus on some of the specific issues that have just been mentioned in the previous presentations. And finally, in cycle 3, we're going to be doing evaluation at scale for all interventions. And doing this type of evaluation on a project which is run in multiple different countries, with different types of interventions, with different age groups of students, etc., etc., it's quite a challenge. So I'm going to focus on talking about the cycle or year 1 evaluation. And to address those challenges, and there are a number of different design principles. The first was that the research should be exploratory. There's a dearth of literature in this area, but also we're piloting a number of things. So an exploratory approach is most appropriate. We wanted to take a holistic approach to look at what's done both in the classroom physically as well as online, to consider the teachers' perspectives, learners' perspectives, but also the observer's perspective. And we wanted to be open to emergent findings. So there are particular things we wanted to look for, but also we wanted to stay open to the unexpected. So the research methodology that was used was exploratory case studies. They used a mixture of qualitative and quantitative data collection and analysis. Qualitative there is capitalized and first because it was the primary source of data collection. It was the one that was used first in the data analysis. And as you can see from the list there, it was the majority form of data collection. And then when it came to data analysis, each of the case studies was analyzed on its own using constant comparative analysis, starting with the open interviews with teachers and students. And then identification of critical incidents, where we looked at what was happening through the observations, if they were mentioned in interviews, perhaps maybe teachers' reflective diaries reference them. We looked to see what were the antecedents and what the impacts were as well of those critical incidents. We then took the case studies from the different countries and did a cross-project thematic analysis and descriptive statistics of the survey results with some t-tests where statistical significance looked like a possibility. And what I'm going to do now is talk to you about the results from that cross-project analysis. In terms of the highlights, the students really valued and enjoyed the projects that they participated in. I'll talk a little bit more about different aspects that they particularly enjoyed, but one of the biggest challenges across all the projects was time management, and that was the students' own management of their own time. The projects were also really valued by the teachers. They really valued the approaches, they valued the technologies, but the biggest limiting factor for them that they perceived in terms of future uptake was time. The projects were very successful in relation to the learning outcomes that the teachers had identified in advance. However, it was challenging to provide evidence of learning in all circumstances. And what was clear across the projects was that the empathy, feedback, and delivery, which are specific to design thinking approaches in the classroom, were some of the most valuable activities for the students. If we look at what we know from the literature about design thinking activities in classrooms and the challenges that have been identified from that literature, we see those first 6, actually, we were very successful in this area. Students did not generally report frustrations with technologies. They were not frustrated working in teams. And where I've put their male students and female students, that's just where there's a statistically significant difference between the genders. What we did find was that students were generally neutral in their opinions about whether or not they were able to redesign their own solutions, and this tended to come down to factors around time. Where we continue to see challenges, as I've mentioned, time management is a big challenge. Students, because of time pressures, were not always able to complete everything that they wanted to do or expected to do. And they were also somewhat frustrated that they didn't get any feedback on how they should be working as a team. So if we take that issue of time, the single biggest challenge for teachers, the interventions lasted between 5 and 8 hours. And as you've been hearing, sometimes they were one-off events, one-day events. Sometimes they were 1 or 2 hour lessons spread over several weeks. Where the interventions took place in less time, the phases were typically shortened, the design thinking phases were typically shortened. And as a result, teachers felt there was insufficient engagement from students. They tended to have a lack of understanding, and they were frustrated in these shortened phases. And the teachers themselves felt under pressure where these phases were shortened. They felt that they couldn't do everything that they needed to be doing. And because of this sense of pressure, some of them felt that they were unlikely to consider doing design thinking activities again. Timetabling is a big challenge in doing this type of activity, and teachers also raised concerns around curriculum coverage. When we look more closely about design thinking actually in action in the classroom, we split it into 2 halves. The discover and define phases were really valuable in terms of getting initial active engagement from students. This is where they started meaning making. And from a teacher's perspective, they saw this is where students actually had buy-in to their projects, which sustained them throughout the projects. And this was particularly emphasized in relation to empathy, the empathy phase. However, only 43% of students actually reported finding out about the needs of others. Students did identify these phases as their main learning opportunity, but they also identified it as the most time-consuming. When it came to the second half, the design and deliver phases, students found these the most interesting and the most challenging. There were clear opportunities for all students to engage, regardless of past experience or knowledge. And there was evidence of them engaging in creative expression and creative thinking. Students valued the opportunity to share what they'd created and gain feedback, particularly male students. But these opportunities were most likely to be restricted due to time and the features of technologies. Students also reported needing both support and time to be able to give and act on feedback, but only 19% said that they didn't have any opportunity to engage in feedback processes. When it came to the technologies, we see that the project technologies align broadly with device use, students' existing device use, I should say, but not in terms of application use. Students, young people, tend to consume, not produce. And they highly valued the project technologies for rapid prototyping. The majority used Choico, which was easy for them to use. There were some bugs and there was some reports of limited functionality, but broadly they enjoyed using Choico. When it came to Sorbet, it was felt to be particularly easy to use, but possibly too simple for older students. Enquire was identified as particularly time-consuming, but it was probably the technology that had the least familiarity. And when it came to Malt2, the one used for designing the garden, the vertical garden, this was most challenging for those students who didn't have previous experience, but those who had previously used Malt2 found it quite easy to use. So the main issue when it comes to technology is one of time. And that's a combination of factors around familiarity and complexity of the technology. And as previously mentioned, there is a need for easy to use manuals or videos for students to support student engagement with these technologies. The idea of using design thinking with emerging technologies is to help support and foster 21st century skills. We've mentioned time management before. This was a big challenge for students. Interestingly, before they did their design thinking projects, they were generally confident about their own abilities around time management, but by the end, they recognized it as a challenge and a skill that they needed to develop. Some of them said that it was linked to the fact that their projects were too ambitious, and maybe they needed some oversight, some review from teachers and help to narrow down their projects. There were also no specific opportunities for them to develop these skills. When it came to team working, though, the opposite was the case. Before the project, students were less confident in the pre-survey about their team working abilities, but generally they were very successful. And we saw that both in the survey results and the observations and interviews. Most referenced team working as a skill that they developed through the project. And interestingly, several of them talked about how the design thinking project has actually transformed their way of thinking and working in a team. And as we know, team working requires strong communication skills, particularly listening. But communication was not recognized in any of the intended learning objectives in the activity plans set out by the teachers, yet they were essential and they need development. Retrospectively, teachers then identified design thinking as actually a really valuable opportunity and a way to develop this as a skill. Listening skills were particularly essential, and where students struggled, this was a site of frustration. Consensus building and taking alternative perspective skills were also needed. What was quite interesting was that both students and teachers talked about collaborating in teams and using digital tools as opportunities to engage in critical reflection, both on their actions, but also in terms of what they were learning. But again, reflection was not explicitly referenced. And when it came to digital skills, programming was the most mentioned skill. At the start, Chronis mentioned about teacher professional development for initial teacher education. And we had 2 teacher education courses running this past year, one in Greece and one in Belgium for in-service and pre-service teachers. They were based around an experiential learning approach, where the teachers both learned about the project technologies and design thinking, but also engaged in design thinking activities using the project technologies. I'm not going to go into the details of the evaluation. It broadly aligns with that of the school interventions, but it is really valuable in terms of thinking about teachers and student teachers' knowledge, their experiences, their own experiences in the classroom as students and as teachers. And it helps to provide an important evidence base when we're thinking about the recommendations from this first cycle. So when the teachers were being students themselves, the challenges that they experienced were also around time and their own time management. So it's perhaps not surprising that our school students are struggling with time management when the adults are as well. There were also questions about the feasibility of these types of projects in schools in relation to time. When it comes to the different phases and different activities in a design thinking project, divergent thinking was an area where students really tended to struggle. What the teachers would tend to do is that they would want to try and find the answer, the solution. And yet these are purposefully ill-defined problems with no single solution. And it was very clear that their past experiences, their attitudes and their assumptions came to bear in terms of their reported experiences in these projects. In Greece, teachers stated that they tended not to use feedback in the classroom as part of learning. And in Belgium, the idea of productive failure in the classroom was quite alien. These are both key parts of design thinking. And when it came to themselves, teachers reported having a sense of low self-efficacy when it came to solving problems with no single correct solution, which is interesting in relation to the divergent thinking. and also low self-efficacy when it came to analyzing different arguments, perspectives, or solutions. And yet this is what we're asking the school students to do. When it came to whether or not it was feasible in school, main issue that teachers highlighted was time, but they also made reference to lack of resources available to be able to use with their own students. This was particularly raised in relation to the technology, but also the empathy phase of design thinking. Yet to them, one of the biggest strengths of the activities was the practical and meaningful integration of empathy. They really valued the courses that they participated in because they were unlike traditional university classes. They valued the technology, seeing it as an essential piece of the design thinking puzzle. They learned from their peers, and interestingly, they talked about opportunities for reflection. They talked about opportunities for themselves as teachers, as designers of learning activities in their own classrooms, but also opportunities for their own students to be reflective designers, although they did consider that this would be a challenge for their own students. So these two evaluations, along with the results of the co-design activities with teachers, has led to a set of 22 recommendations, which address the challenges that have been highlighted in the findings, along with the reflections from partners on the individual case studies. These 22 recommendations are split between design thinking pedagogy, the technologies that are being developed in the project, the involvement, the engagement with 21st century skills, and the evaluation process itself and ethics, which Manolis is going to be speaking to a bit later on. And returning to our design-based research cycle, here at this analysis point, we're then thinking about these implications for theory, but the implications for redesign. And it's this set of 22 recommendations that are informing the redesign of our activities for the second year or second cycle of our project. Thank you very much.
Thanks, Carina. That was very detailed. Thank you. If you have any questions, please use the chat or the question and answer section. And we move to our fourth presentation for today about extending technologies from Marcelo and Marianthi. Please to share your screen. Thank you.
Yes, I will share the slides, and Marcelo will start.
Okay. Good afternoon, everyone, and nice to have so many people here. So what Marianthi and I will present briefly in 10 minutes is the technologies we're using and in which way we look at the affordances of these emerging technologies. My name is Marcelo Milrad. I work as a professor at Linnaeus University, and I'm the principal investigator of this project. Marianthi, please introduce yourself.
Yes, I'm Marianthi Griziotzi, and I'm a postdoc researcher in National Kapodistrian University of Athens.
Thank you. So what is the main idea of the emerging digital technology for design thinking? As Chronis, the second presenter, was talking about different emerging technologies we're using. We're looking at how to introduce augmented reality, artificial intelligence, and 3D printing among the different tools we have. There are a number of tools that have been existing before that they rely on web-based technologies. And the idea is how through the pedagogical integration and didactics could be combined with the different design thinking activities. And through a number of interactions, we're looking about how to enhance those tools with these emerging technologies. So to the next slide, please. And as it mentioned, there are 4 different tools. One is called MALT2 for working with the language logo-like or text-based for combining coding and visual representation of complex topics in mathematics and programming. Another tool called Choico in which people do visual programming, Sorbet, a tool for sorting things and combining different type of interactions, and visual robotics, as Sofia mentioned, is in one of the interventions that have been done in Norway. So we combine different tools with the different affordances and the idea of the emerging technologies to bring new perspectives to these tools in connection to design thinking. So Marianne, move ahead. Marianthi. So it's your turn.
Okay, so yeah, thanks. The method we used, as also Carina presented before, is design-based research, and we use this method also for the development of these technologies. This means that in the first cycle, the first year, we did a requirement analysis for how to extend these technologies and some pilot implementation with the existing tools. We collected and evaluated some data, and we came up with some recommendations based on the analysis. And with these recommendations, we will we designed the extended versions of the technologies that we will use in the second cycle next year, in which we are going to do a small-scale implementation, collect data, and go to the third cycle that we will refine our technologies and do some larger scale implementation with users. So right now we are in the beginning of cycle 2, actually. We have already, and now I will show you how we extended these technologies. The first one is Malth2 3D Modeler. I already showed you how it was used in year 1. In this, I will actually show you the technology live. So in this technology, students can create some, just give me a moment. Yeah, students can create 3D models using a simple programming language. Here you can see for example, they have created the letter T by using some simple commands. This model is animated on the screen, and it can also be drawn in the 3D space, so they can create a letter T that goes into 3D and has this curved line on top. So this is the original model. With the extended version, the students can export this object in a simple file, and then have this model printed with a 3D printer. So this is how this model was printed, and it can be, for example, be stuck and decorate a cup of coffee. And we have done this with many different letters to create them in 3D shape and having them printed. So the added value of having our 3D models printed with a 3D printer is that they give access to models that are complex and hard to imagine, like this example. Also, the students can do an iterative design testing of how of the digital and physical artifacts, and they can connect digital learning and digital constructions with physical constructions that are actually useful for solving real-world problems. The second technology is Choico, choice-driven, that students can play and design choice-driven simulation games. In the extended version, which I will show you right now, students can use actual Google Maps to create such games. In this example, it's a simple game I created where it's my neighborhood, and I can select to visit different points in the game, like go from my home, from my house. I can go to my home, for instance, and see how it affects fun, money, citizenship, etc. But there is this extra field that it's called travel time. And it actually adds to the game real-time traffic data from what happens right now in the streets. So if I select to go to the local museum, for example, I can see that it took me 3 minutes to go there. And if I go back to home, I can see that it took a little bit less because I followed a different way, or the traffic was reduced. And I can see actually the live traffic data and make my choices in this game. And more in addition to that, I can edit the game. So here I can add more points or change the consequences. Go to my current location, which currently is not there. It's in another place on the map, and add a new point to my current location, for example. And in that way, I can design games in a larger or smaller scale on Google Maps based on where I am. So I can add different points as a designer based on geolocation and where I am at the moment when I design the game. So the third, So how does this extension, the Google Maps extension, adds to the to learning? It allows students to empathize with real-world problems, to discover local issues as they design the game outdoors or adding new points on the map while walking around on the streets or on a park. And also it connects design thinking and map design with data science learning as they collect and manipulate data. Finally, the third tool, that is this survey game where students classify falling objects, was extended with an AR body recognition technology that allows many students to play at the same time the game using their body movements and their gestures, their hands. We believe that this adds to the previous version because through collaboration, students can express more ideas. It allows for embodied learning experiences and learning through body movements, and allows also students to design their own augmented reality classification games for others to play. So Marcelo can say a few words about the analytics technology we use.
Yes, and one important aspect of all these tools, and one of the ideas of the main project, is how to use digital media to support design thinking. And one characteristic, can you press, just I want to, if you can click, no, just I want to go to the end of this slide. If you click one more time, please. Yes, that the challenge is, I guess most of you are familiar with the idea of learning analytics, that is to use a number of artificial intelligence techniques and visualization to allow teachers or educators to deal with digital collected data. And the challenge we are facing in this project is what type of user-generated data is interesting to capture, to visualize, when most of the challenges, they're open-ended, because it's not just solving a task in math or solving an engineering problem in a given path, but it's more open. So this is one of the challenges. So if you move to the next slide, please. Is that is the idea of learning analytics in the making, and the idea is, the main challenge is what data should be captured, in which way should be visualized, is any important feedback in terms of recommendations or some machine learning clustering to be activated, what and when. And there are a number of affordances in which way these techniques could be used to help teachers to collect, visualize, and analyze the student data, because this is a major challenge in purely digital learning environments. So we are exploring the idea of having learning analytics dashboard that is authorizable. That it means that teachers can select different features in which these techniques could be used to help teachers and even students on how to support the kind of activities that Marianthi has been shown and the other colleagues. So if we move, just to give a very simple examples. So this is one example of the activities that Marianthi was showing with this tool called Choiko, in which different techniques could be used to give teachers domains in which Choiko has been used by different groups. The classroom could be divided in working groups, so the teacher can select what are the type of problems, duration of the activities, and so on. So if we move on to another example with the other tool, is with MALT. This is a little bit more complex because it's to look at different ways on the outcomes in terms of skills, describing which are the mathematical objects that have been dealt with, and a little bit the analysis of how the code has been used. You can see in the bottom of the page on the right side, you see operators, structure code. So this type of tools that can help teachers to gain new insights on what is going on where the students are using these tools to support design thinking. So I think it's just one more. And then we move back to you, Marianthi.
Yeah, so in the final slide, we are just visualizing how we implement these technologies into the different stages of design thinking. So for example, teachers can give to the students to play a Choiko or a sorbet augmented reality game to understand the problem. For instance, to go and play outside with a Choiko geolocation game to discover and understand the issue of their project. Next, they can use either of these technologies, MAL2 or Sorbet or Choiko, to define which are the key elements of their digital construction and how they will respond to the problem. For example, which city area they're going to focus in a geolocation game. Then in the developed stage, they create prototypes with the tools and test them with others. And the use of technologies helps to this sharing and testing and this rapid prototyping. And finally, they can share their digital artifacts easily online through Enquire or other platforms and get feedback for what they have created. So in this way, we try to embed these technologies and the emergent ones into the different stages of the design thinking. And analytics and AI that Marcelo presented are covering the whole process since they collect data during the whole activity and to give teachers feedback of what the students have done. So thanks a lot again. Here you can find again, this is the link of our project and our emails.
Yes.
And we will
Thank you so much, Marianthi and Marcelo. We're moving to our last presentation for today. It's about opportunities and challenges related to AI from Manolis. Manoli, over to you. Thank you.
Yeah, hi. Thank you. Thanks, everyone. Thanks, Sofia. I'll connect the discussion from the point that Marcelo left it around the AI and the analytics in the project, if I manage to share my screen. Yeah, so I'll try to broaden a little bit the discussion following from the specific of the project, both about generally about artificial intelligence, opportunities and challenges, but contextualized in this space of the Exten project and design thinking and so on. I'm Manolis Mavrikis. I'm a professor at the EACEA Knowledge Lab, where generally we're exploring how emerging technologies, particularly AI, is shaping education and or shaped by education as well. You probably don't need me to say that AI is everywhere, and that once it was kind of confined in science fiction or movies and so on, but is now evolving into every aspect of modern society. In the interest of time, I will not go to the specific details of the timeline, but I want to show and remind ourselves and also newer ones in the area that there is a strong history that goes back many years. In the last decade, there has been an exponential growth, exemplified mostly the last few years by the fact that some of these tools have become more public, and there's awareness that is moving out of labs into the real world in different sectors, but also in education. I'm talking especially about approaches like OpenAI, ChatGPT, and so on. But if you are interested in this space, it is worth to look at the history of the field, particularly its applications in education that go back more than 40 years of research with various approaches. This paper, for example, is a state of the art that goes back to different categories, including the typical intelligent tutoring system that is expected in this area, but also broader. My work tends to be around the instructional approaches and being able to provide feedback, which we have summarized in this work. But with AI emerging and with any transformative technology, this kind of evolution brings with it many critical questions and considerations. So the last few years in particular, the society is critically examining the different impact that AI can have. And so perhaps one of the, again, if you as an interest, one report that some colleagues at the lab actually worked on from the Council of Europe characterizes the core values of the Council of Europe. And I'd like to bring them in the context of this project. And basically an understanding that there is an influence on learner autonomy, mostly, but also various ethical dimensions that AI introduces that need to be addressed. The report also calls for evidence-based research, which, of course, we are responding to by evaluating these approaches. So bringing it to Exten specifically, we are in the process. It is early stages in relation to this particular strand of the work, but we are reimagining what AI could mean in data-driven pedagogy in this particular space. As I mentioned, most of the work so far in applications of AI in education has focused on naive behaviorist methodologies, where the idea is that you sequence material or that you give questions or quizzes to students that are adapted to their needs, and that's necessary sometimes. I'm not diminishing it, but there is a critique that they tend to prioritize memorization and procedural knowledge. But you will have noticed so far that in Exten we are talking about the design thinking approaches meeting constructionism and meeting artificial intelligence now. So we need to respond to the fact that what Marcelo mentioned as well, there's creativity, problem solving, experiential learning, and active engagement in all of this. And AI doesn't always sit hand in hand with this kind of approach. So one particular emphasis that responds also to these critiques in the field has to do around autonomy. You've noticed the tools and the different problem-solving challenges that the students are engaged in. And so this emphasis on being able to provide the intelligent support on these more exploratory learning environments requires more acknowledging these kind of experiences that someone would have, and prioritizes that we need to have more inquiry-based learning, allow the students to formulate and explore their own questions, make mistakes and learn from these errors, and occasionally benefit also from feedback when they need it. And so the role of feedback, particularly if we talk about feedback and AI, it's not to give them correct answers and so on, but to be able to detect these kind of different paths that they take and adapt. We are relying on previous work on an authoring environment we call Othello. I don't have a lot of time to go into the details of it, but the main thing is that we are lowering the threshold of the possibilities for providing feedback from different stakeholders. But it could be teachers, it could be learning designers that can configure the data that the tools collect based on simple user interfaces, but also write simple rule-based constraint satisfaction systems that have the opportunity to give feedback to the students when needed. So to some extent, with this, we see this whole system as a micro world within a micro world, where you are able to play and modify the feedback that it gives. But of course, another aspect that was mentioned in the Council of Europe report, for example, is data privacy and protection. And this is the other angle where there are, again, opportunities and challenges. It was mentioned already, like we need to think what is the data that's necessary and sufficient to be able to record this interaction. Is any student's rights to privacy maintained, and how informed are the students, and so on. I'm finishing soon. Just want to acknowledge that we're aware we need to address this. This kind of issues is always at the heart of all educational technology projects, this data privacy. We as a research project, we tend to be kind of privileged to be behind a research proposition, and so we get obviously informed consent, we comply with GDPR, there's no commercial use and so on, but this does not necessarily absolve us from these practical questions that we need to address and make sure that there is transparent data collection, there is right to access and delete the data, especially if we think after the project what might happen with the technologies. And finally, the responsibility to minimize any costs that errors have when decisions are taken, and also continually refine the systems to avoid any, to make sure they're fair at least. So I think in this short time, I hope I covered both some significant ground in terms of the history of the field, but also the specifics to the project, and the opportunities and the challenges. As you see, there are many questions ahead, and we welcome discussions with anyone who has answers to this. I'll stop here with this image that I hope just give some food from thought. It's from some students at the UCL Education and Technology Masters using AI to draw it, to depict these autonomy issues that we're facing, bringing both design thinking and constructionism and AI all entangled somehow with the learner and teacher autonomy together. So I'll pass this back to Thea, I guess, will coordinate questions. Yeah, thanks.
Thank you so much, Manolis. It's a nice picture to finish up the session produced by AI. So we have 16 minutes for questions. I haven't seen anything in the chat. But if you have any questions, please type them into the chat or in the Q&A section. I don't know if any of the co-presenters would like to share any thoughts about the session and more broadly while we wait for questions. Well, actually, thanks all of the participants for joining the session. Please, if you have any questions, this is the time to raise them. Perhaps you should say that if you're interested in the project and the progress and what we are doing in the next few months, you are more than you're invited actually to reach to any of us, and we can keep you posted about progress. Also, if any of you have contacts with teachers that they are interested in trying new things with the students, we are organizing in the next few weeks until probably January to offer workshops to teachers about how they can use our technologies and how they can use design thinking in their practice. So there will be workshops across all of the participating countries. So if any contacts you have, they would like to take part in those workshops, they are more than welcome to join us. They are free workshops, and I think most of them will be online. So there is an opportunity for any teacher to join. Sofia?
I see something posted on the chat. It says, it's a question, I think it's about AI. How did you do for creating your database? From Natalie. Maybe Natalie, you want to say a bit more, or maybe this question was for Manolis from the last presentation.
Maybe for Marcelo to chip in as well. The short answer is that all the systems are using this protocol called EACEA, and the data travel from the different systems in the same database in this format, whereby depending on what kind of session or data you select, you can see the visualizations that Marcelo showed before. I don't know, when I add anything, Marcelo or Natalie, we can take this separate as well if you're interested in this. There's another question.
I think you explained it quite well. So I think it's another question, maybe
for Carina.
For Carina, that says, what do you mean by instrumental case studies? What's the difference with explorative ones?
Yeah, so this comes down to kind of different definitions of case studies. So generally using Yin and either Robert Yin or Robert Stake's definitions. In terms of exploratory case studies, these, as I said, they work well for pilot studies. They work well when there's a dearth of literature in the area. So you're looking very broadly to see really just what happens, staying very open and very emergent, and looking at as much as you can from as many different perspectives as you can, you know, and obviously there's limitations to all of that. An instrumental case study is studied because there's something specific about that case study that you want to find out about, right? So, for example, in our cases, developing the technologies, we want to see whether or not the enhancements that have been made to the technologies do what we expect them to do, for example, right? So we might have an instrumental case study that's focusing on that. It'll be happening within this design thinking context. All the other things will still be happening, but we're focusing on that aspect. Equally, we might be particularly interested in how teachers effectively facilitate the empathy phase, or we might be particularly interested in techniques around generating feedback and how students then use that feedback. So in those case studies, they'll be focusing on those particular phases of the design thinking. So I hope that helps answer your question.
Thanks, Carina. There was one more question about workshops, and I shared in the chat the project email address and also a webpage in our website. They can find out more. Well, it seems that there are no more questions in the chat. I would like to thank all of you joining the session, and also our presenters for explaining clearly what we have been doing for the last year of the project. We hope that we will progress further this year, and we will have more to share with you probably same time next year. So hopefully you have another opportunity to present then. Thank you so much. And also thank you to the organizers for facilitating and organizing the session. Thank you.